Hello guys, in this video we are going to discuss the solution of the problem subarrays with sum k. So let us look at the problem statement. The problem statement says given an unsorted array of integers, find the number of continuous subarray with sum exactly equal to a given number k. So for instance, if this is the array which is given to us and the value of k is equals to -10, then there exist three subarrays with sum equals to -10. Those three subarrays are array starting from index 0 and ending at index 3, array starting from index 1 and ending at index 4, and array is starting from index 3 and ending at index 4. And that is why we are returning 3 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, what we want to do is we want to compute prefix sum. What is prefix sum? Well, prefix sum is essentially sum of all elements so far. So for instance, if I am at the ith index, then the prefix sum is equals to sum of all the elements from 0th index till ith index. And this prefix sum is something which we are going to store in a dictionary or map, and let us call that dictionary as prefix sum. So the dictionary consists of key and value. Over here, key is the prefix sum and value is the number of times we have observed this sum. So for instance, let us say the current prefix sum is 10 and we have observed 10 twice, then the value will be 2 over here. After doing this, let us store the current prefix sum in a variable called current sum. And let us check whether current sum equals to k. If current sum equals to k, then that simply means we have found a way by which we will be able to arrive to k, because of which we are going to increase our answer by 1. And additionally, we are going to check if current sum minus k exists in prefix sum dictionary. If current sum minus k exists in prefix sum dictionary, then that simply means we have found a way by which we will be able to achieve to k. In such case, we are going to increase our answer by prefix sum of current sum minus k. So that's the general idea behind solving this problem, folks. Now let us take an example to understand it completely. So let us say this is the array which is given to us and the value of k is equals to -10. For this, let us have a prefix sum, and initially the prefix sum dictionary is empty. And then let's have a current sum. The value is 0 and answer equals to 0. Now the first thing which we are going to do is we are going to compute the prefix sum. So the prefix sum is given by sum of all the elements so far. So the first element which we have is 10. So the current sum will get updated and the current sum becomes equals to 10. So current sum becomes equals to 10. Now we are going to check whether current sum is equals to k. Since it is not equals to k, we are going to skip it and we are going to store this current sum in the prefix dictionary. So let us do that. So over here we got 10 and the value associated with 10 is 1, which simply means a sum of 10 has been observed and it has been observed once. Now we move to the next element. The next element is 2. So the current sum become equals to 10 plus 2, which is equals to 12. Now again, we are going to check whether 12 is equals to k. Since it is not equals to, so we are going to keep answer is equals to 0 and then we are going to store this 12 in our prefix sum. So in the prefix sum, 12 and corresponding to 12, the value is 1. Now the next element is -2. So current sum will become equals to 12 minus 2, which is equals to 10. Now is 10 equals to k? Now since 10 is not equals to k, because of which answer remains equals to 0, and we are going to mark an entry of 10 in prefix sum. Now in the prefix sum, since 10 already exists, because of which we are going to increase this value by 1 and this value becomes equals to 2. Now the next element is -20. So current sum becomes equals to 10 minus 20, which is equals to -10. Again, we are going to check whether current sum equals to k. In this case, current sum equals to k, because of which we are going to update our answer by 1 and answer becomes equals to 1. Similarly, we are going to mark an entry of -10 in our prefix sum. So this value came over here. So -10 and corresponding to -10, there is 1. Now the next element is 10. So current sum will become equals to -10 plus 10, which is equals to 0. Now we are going to check whether current sum equals to k. Now current sum is not equals to k, because of which answer remains equals to 1. And now we are going to make an entry of this current sum in our prefix sum. So 0 corresponds to 1. Now folks, at each step we will also be computing something known as current sum minus k. So what do I mean by this is, it might be possible that x plus k is equals to current sum, which simply means the current sum which we have computed so far, within that current sum we have already observed k. So in such case, x will be equals to current sum minus k. So what does this mean? Well, what it simply means is, at each step we are going to check whether current sum minus k exists in the dictionary or not. So let us do that. So over here, if you compute current sum minus k, so let us compute current sum minus k. So this will be equals to 0 plus 10, since k is equals to minus 10. So current sum minus k becomes equals to 10. And we are going to check whether 10 exists in our prefix sum. Since 10 exists in our prefix sum and this is equals to 2, then that simply means there are two ways by which we will be able to make 10, because of which the answer will get increased by 2. So answer becomes equals to 3. And please note folks, we are going to compute this value, which is current sum minus k, at each step. So over here I have just computed at this point, but then this value current sum minus k is being computed over here, over here, over here, and so on. At each step we are computing it. Now in this example, it turns out if you compute current sum minus k, we will not get a match, because of which it is not affecting our answer. And in this way we will be able to compute the subarrays with sum equals to k, and towards the end this is what we are going to return. So that's the discussion of solution folks. Now let us discuss the pseudocode of this problem. So let us say we want to compute sum with k and an array and k is given to us. For this, let's have our prefix sum dictionary and let's have current sum and answer, and let us initialize it with 0. Then we are going to iterate on the elements of the array. So for element in array, and we are going to compute the prefix sum. So prefix sum will be given by current sum plus element, and we are going to check if current sum equals to k. If current sum equals to k, then in such case we are going to increase our answer by 1, and at each step we are going to compute current sum minus k. So we are going to check if current sum minus k exists in prefix sum. If it exists in prefix sum, then all we have to do is we have to increase our answer by prefix sum of current sum minus k, and as usual we are going to make an entry of current sum in the prefix sum dictionary. So the way we are going to do this is prefix sum current sum is equals to prefix sum dot get current sum. If let's say current sum does not exist, then 0, and we are going to increase it by 1, and towards the end we just have to return our answer. So that's the pseudocode folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here prefix sum is a dictionary, answer and current sum equals to 0, and then we are iterating on the elements of the array. We are computing current sum, which is equals to sum of all elements so far. If current sum is equals to k, then answer we are increasing it by 1. Otherwise we are checking whether current sum minus k exists in prefix sum. If it exists in prefix sum, then answer is getting increased by prefix sum of current sum minus k. Otherwise we are increasing prefix sum current sum by 1, and towards the end we are returning answer. So that's the Python implementation folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same folks. Prefix sum is a dictionary, current sum and answer equals to 0, and then we are iterating on the elements of the array. We are computing current sum, which is equals to sum of all elements so far, and if current sum equals to k, answer is getting increased by 1, and we are checking whether current sum minus k exists in prefix sum. If it exists, then answer is getting increased by prefix sum of current sum minus k. Otherwise we are making an entry of current sum in the prefix sum, and towards the end we are returning answer. So that's the C++ implementation folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.